Gestalt IT is proud to present the On-Premise IT Roundtable. On this episode, we're clearing up some confusion that's been caused by the fine folks in marketing. Caching and tiering each have their own role in enterprise storage. The Roundtable clears up the technical differences between the two. To follow all the participants on the Roundtable and to get more episodes, be sure to check out gestaltit.com/podcast.
I'm Stephen Foskett. I'm the organizer of the Tech Field Day event series and also of Gestalt IT, and this is the Gestalt IT Roundtable podcast. Thanks for joining me. Today we have a panel of folks from Storage Field Day 11 here in beautiful San Francisco, California, and we are talking about a very, very nerdy storage topic. We are talking about tiering versus caching, and as Curtis points out, does it matter? We will certainly end the discussion with this definitive conversation. So let me start off with James.
I'm James Green. I'm on Twitter as @JDGreen.
W. Curtis Preston from Storage Switzerland. I am at WC Preston.
Chris Evans at Chris M. Evans on Twitter.
Alistair Cook at Dimitas NZ.
You know, yours is the only one that's not your name.
It is, and that was a conscious but probably foolish decision.
Yes, you are just like a real short cup of coffee.
Small and powerful.
Small and powerful. Excellent. So speaking of small and powerful, well, actually, that's not a really good lead-in, but what can we say? So tiering and caching. As long as there has been storage, there has been a discussion of tiering and caching. I remember one of my first storage array purchases was an EMC Clarion. And what was the innovation of the Clarion? Caching. Really, really smart caching. And that's why this little box became the big box. You know, this little box could do many powerful things. But now we have tiered storage, we have cloud storage, we have gateways, we have all sorts of things. And there's confusion over exactly what we mean by tiered storage, by caching. So my metaphor has always been this. Your house is tiering, the hotel is caching. You know, you can temporarily reside in the hotel, but eventually you're going to go home, probably. If you've got a house, right, you can move to a bigger house, you can move to a smaller house, you can move closer to your job, whatever, but that's your house. That's where you live, and you don't generally it's not temporary. You know, is that a good metaphor?
And in tiering, you are permanently changing the location of the data, whereas caching, you're just making a copy of it at a different place. Mm-hmm. How's that?
Okay, so we're all in agreement.
Yes.
Yeah, and there's another way to characterize it as well, which is that if you are using a tiering, then the fast piece of storage counts towards the capacity of the overall system.
Yes.
Whereas if you're using caching, only the slower component of the storage counts as capacity. The fast piece is not a persistent capacity if it's a cache.
Yeah, that's a really good point.
It's a good way of identifying.
Yeah, so if you've got, 900 gigs of slow storage and 100 gigs of fast storage, and the total usable capacity is a terabyte, then we are tiering. And if the total usable capacity is 900 gigs, then we are caching, no matter how you've implemented it.
Correct.
Well, we've solved it, right?
Yeah.
Why is there controversy here?
Why do vendors sometimes refer to one as the other?
So
why do vendors who do caching keep trying to call them tiering?
you need to look back at why you do them in the first place, I think.
Yeah,
So-
let's unpack this.
So caching is done because you can't afford to put all of your data on the fastest possible storage.
Right.
And in most architectures, it's physically impossible to put all of your data right next to the processor.
Right.
You would love to put all of your data in memory. It doesn't work, and the memory is not persistent. So you cache to allow you to access the data that you want to get to, which is typically not all of the data.
Right.
Because only a subset of your data is ever busy at any one time. So you cache what is active in order to basically make it look like it's all sitting on expensive storage when it's not. And tiering is about trying to predict what you think is going to be the most active data and moving it around in order to optimize the cost of buying persistent storage.
Caching to me is more about performance. Tiering is more about cost. How's
To a
that?
certain degree,
It's an interesting perspective.
Tiering tends to be, we're going to put the less used, it's almost the other way. We're going to take the less used data and put it on slower storage and maybe even more slower storage, God forbid, even tape, right? But whereas caching is more about taking and improving the performance.
Now that is an interesting perspective. So in other words, so it's the direction of the data. Is it flowing towards slower and cheaper, or is it flowing towards faster and more expensive?
And obviously it can be yanked back, right, if it gets hot again. But it's, again, to me, it's about moving versus copying. And I guess the answer to my earlier question is that tiering sounds sexier and newer than caching, which is why vendors who clearly do caching are calling their products tiering.
But there is a little bit of fatigue on the idea of tiering as well, because there are tiering schemes that happen overnight, and so what was hot today is suddenly on your fast storage tomorrow, but what's hot tomorrow is going to be different from what was hot today. And so there are some places where this idea of tiering is a bad thing.
Correct.
And that caching is more likely to deliver the performance that you want, honest, because my product caches.
And then, of course, there's also a lot of these cloud gateway products and so on that cache 100% of the data.
Yes.
So in other words, every byte that lives in the cloud also lives internally. For example, Dropbox on your laptop, right? That is clearly a cache, but it is, all of the data is right there on your laptop versus Dropbox on the iPhone, which is much more obviously a cache because the data is not on there unless you've recently accessed it.
So just to follow up on Alistair's comment, I think there's a really important discussion there, and that's almost all tiering solutions are reactive to the profile of the data. And they look at it post-process either very quickly or over a longer period of time, and they make decisions to move stuff around in a reactive way. Whereas theoretically with a cache, you can use a cache to get stuff or to get access to data very, very quickly compared to a tiering solution. So you can write to the cache as well as read to the cache. So you can potentially speed up write I/O, which you couldn't do with tiering, because tiering would move stuff around too slowly.
Sure, you could. A tiering system can work the same way, where you write everything to the fastest tier first, and then if nobody looks at it, then it eventually gets moved.
So that's why I said almost all of them, rather than all of them.
I missed the A
is
word.
a good example of one way it writes to the fastest tier and cascades it down afterwards. But yes, I agree, that's still, that is a subset of it that loads things.
So you just brought up writing, which leads me to the other big question with caching, and that is write only versus, or write through versus write back.
Well, there are three types, aren't there?
Yeah, that's
There's write around. As well.
Yeah. And what do you have to say about that?
So, write back, you acknowledge in the cache, and you give the acknowledgement back straight away. So you need to protect that data, because if you lose the cache, you lose the data. Write through, you write it down to the bottom level of cache, the bottom level of storage through the cache, but it's in the cache. So if it's reread in a short space of time, you can get fast I/O, but you've also got it on persistent storage, so you don't need to protect that cache in a resilient manner. And write around is for when you've got objects that never need to be cached, like an MP3 file or something that you don't want to pollute the cache because it's too big and it's going to get in the way. So those are the three styles. And I think write back cache is great, but obviously it requires a lot more engineering to make sure it works. And it can have problems if you've got something like, say, dual controller architecture in a storage array.
Or a many controller
architecture, where if you lose some of that cache, you end up having to turn it off, and performance sucks. And we know all the products that used to do that.
The way you described it made write through sound great, but what you didn't say is then your ACK won't come back until it's been written to the slow storage, so you have a latency issue to address.
Absolutely.
That, right?
So write through is great if you know you're going to read it very quickly again, but it doesn't help you on your write profile.
So are all those same discussions applicable to tiering? Can you have write through tiers and write back tiers and write around tiers?
No, I think tiering I don't want to say by definition, but tiering, each tier must have protection on it. So you don't really have that. You can write directly to the first tier if that's flash, and you don't have the risk that it's...
But it's fairly common for tiered storage to have different types of protection for different different types. I mean, I'm thinking of, you might have like RAID 6 on your disks, and you might have RAID 1 on your flash to preserve the performance.
RAID 1 is not protection.
Well, okay. But no, you're right. That's definitely been the case. And I think you end up trying to come up with a balance of cost and performance when you're looking at that. and availability does come into it to a certain degree, but that was done because as we got to larger drives, we ended up having to use RAID 6 in order to make sure that the protection loss we had from having bigger drives was corrected by double parity.
Yeah. So, James, when the rubber hits the road and people are trying to implement these things, what do they need to think?
Well, one thing that, with regard to your economic statement just now that I'm thinking about is another thing that comes into play is how you're handling compression and deduplication in the cache or that tier, because obviously the better you can reduce that data, the more you can store in the more expensive disk. And so two things, I guess, are important. How you're doing that, whether that's, inline deduplication or post-process deduplication, and then I forgot what the second one was. But anyway, that's...
Yeah. And of course, that begs another question, maybe for another day, which is compression, deduplication, and single instance storage. Let's fight between those topics as well, right?
Well, certainly if you look at it from a caching perspective, if you're running a VDI solution, that's great to have that data in cache because it can be massively deduped, and you can effectively, save yourself a huge amount of read activity because your active profile is so much bigger effectively because of the dedupe ratios. But we're just blurring all of the technology.
Exactly, and that's what the read cache people say is right there. They say a read cache can be extremely effective because if you take the IOPS out, the read IOPS out, then you're only writing, it actually accelerates the writes because they're not competing with the reads.
So let's go back to the original question, though. Does it matter? Certainly write back versus write through and all of that matters very much in terms of how it performs. But does it, are we just arguing over words? Does it matter whether or not a solution is using caching or tiering? If we're just talking about two tiers, because to me, tiered solution implies at least two, maybe even three, right? Maybe even four. There are tiered solutions that do, a fourth one, which is pretty much going to be tape, right? But does it matter? If we're just talking about a product that has two tiers, whether it be cache and not cache or not, does it matter?
That's a great point, and I think it goes back to Alistair's point of capacity. Essentially, I think one area that it would really matter, whether it's a tier or a cache, is in terms of usable or total capacity. If in my example, if you spent whatever it costs for a terabyte, and you can only ever use 900 gigs of slow storage because it's not a tiered solution, it's a caching solution that you bought, I think that matters.
Yeah. And so the question is, does a tiering solution therefore always cost more than equivalently capacitied?
Depends on your working set.
Tier.
Well,
I'm using too many words up here. What I'm trying to say.
No. A caching solution should always cost more than a tiered solution.
Right.
For the same capacity and performance.
Yeah.
So I think you just touched on it, Jim. So let's go back over that one. It's really important.
So
working set.
Yeah, whether or not it's more expensive depends on how much data is being evicted from your cache to be replaced by something else that's now hot. Because if your working set is relatively small and stagnant, and you can always be reading that out of cache, it changes your economics versus if it's constantly cycling through.
Yeah. So the example would be, say
like
you had
VDI,
or a huge media archive where the access was completely random, so you never had the same stuff being accessed that frequently. And then you just put it all on faster storage and don't bother caching any of it because the cache will
be ineffective, particularly because if you've got large volumes of media that you're going to exceed the cache size anyway. Your active data set is going to be vast. But I think there's another aspect as well that I'm actually oddly siding with Preston on this, is that I don't actually care, or most customers don't care.
Mr. Preston.
Most customers don't care because they care about their application. Does it deliver the performance for my application? And all of the technical details under there is somebody else's problem for the guy who signs the checks.
Right.
Absolutely, the architect who's got to select the products, or more crucially, the people designing the actual products we choose to buy are making those decisions. It's seldom a customer who is saying, I want to buy a tiered solution rather than a cached solution. They'll say, I want a solution to this problem and just give me products that solve these problems.
And it strikes me that a lot of this is just an artifact of the way that we do storage. You know, I mean, if storage was done on a much more microscopic scale in terms of, you know, provisioning and writing and deploying storage to different devices and so on, I mean, it's only because devices are very large that we care to cache them, you know, because they tend to be a mixed set of data. It's usually not a unified working set, like Chris is pointing out. It's usually a mixed set of data, just because the artifact, the historical artifact of LUNs and file systems, you know, it means that there's always some hot data and some cold data all mixed together, or at least in most cases there are. And that's why we have to think about tiering and caching. If it wasn't for that, we wouldn't probably have to worry about it.
No, because ultimately, at the end of the day, we always have latency. If latency was 0, we would never have an issue, and then we could just not even have this conversation.
Yeah. Well, we've solved it. All right. No, really, I think we've gotten somewhere here. So we've come to a few interesting workable definitions of tiering versus caching. We've got copy versus move. We've got, you know, total capacity. We've talked about the different ways of implementing a cache. We've talked about why we do this in practice. I think we've done a good job of this. You guys agree?
Yeah, absolutely.
Absolutely.
All right. Well, it's good to have you do this.
So we can never talk about it again.
We can never talk about it again. It has been solved.
Finished.
Yeah.
It's finished. All right. On our next episode, we're going to cover peace in the Middle East. But until then, this is Stephen Foskett for the Gestalt IT Roundtable podcast. You can find more of these podcasts at gestaltit.com/podcast. And you can learn about this event that brought us all together by going to techfieldday.com. Thanks for listening.
The On-Premise IT Roundtable is once again brought to you by Gestalt IT, home to IT coverage from across the enterprise. Make sure to follow us on Twitter at Gestalt IT and at facebook.com/GestaltIT. Very original. The On-Premise IT Roundtable is produced by Rich Straffolino. That's me. Until next time, from all of us here at Gestalt IT, have a super sparkly day.